This is an intermittent. I don't think it's gonna do it for us, but what I'm gonna do is drive it down the road about halfway to Sarasota. We'll drive it back. Hi. Hello. Oh, you got nothing to say now. Hey there, yo.
Yo!
Oh, what a loser!
So we're nearing the end of my test drive here, and forgive me for the clickbaity title, Idiot Driver Interrupts Mechanics Repair P0299 Turbocharger Underboost. Sorry for the clickbaity title. The guy actually did that at the very end. It appears what happened is he was making a left-hand turn at a green light, and there's no left arrow, so you had to wait till cross traffic stop, or until opposing traffic stops. And I was making a right-hand turn at that same green light. So because I was making a right and he was making a left, crossing into opposing traffic's lane, I had the right-of-way. When I made the right-of-way around that corner, the guy then made his left-hand turn and decided to pass me in the oncoming traffic lane and staring at me. When I pulled up next to him later on down the road at a red light to ask him why he did that, he just looked away and had absolutely no balls and couldn't even look at me in the face. He did wrong and he knew it, but he has no self-control because nobody ever taught him manhood. So I will call him an idiot. He interrupted what I was doing, and that's hence the clickbait title. So sorry if I baited you guys into one. Opportunity presented itself, so I took it. What can I say? Plus, I got to shame an idiot on the internet, and that's always fun. What mosquito? There's a mosquito? It's like 32 degrees below zero out today. Unbelievable. Hello, everybody. Good day to you guys. Welcome back to the channel. We're here on a nice casual Black Friday. We're not shopping. I'm a producer, not a consumer on consumption days. So we're here at work, and I'm trying to diagnose I've got this I think it's a 2020 or a 2021 Chevrolet Trax, little SUV thing. It's a 2020. It's got a 1.4 liter turbocharged 4-cylinder engine, kind of like the Chevy Cruzes and a similar engine to the Malibus. This is the little SUV version. It's here with a P0299 trouble code stating that the turbocharger is performing below expectations. It's an underboost code. That can be caused by a few things in this engine. Now, on Wednesday before Thanksgiving, I spent a couple hours trying to diagnose these things, and I came up with a lot of dead ends. I checked all the common stuff that we've actually been over before on the channel: the intake manifold check valve, the rocker cover / valve cover, PCV system issue. That doesn't seem to be the problem here. I don't think it has a broken piston. I've checked all of the wastegate actuators. I've checked the wastegate diaphragm for the turbocharger. The wastegate is what is used to relieve pressure that's been built up from the turbocharger when the driver comes off the throttle and it is no longer asking for power. So when you're no longer asking for power, the ECM says, hey, no more throttle, no more power production. Well, the turbo has already created a bunch of boost pressure for the engine. So you have to have a way to dump that pressure. So we have what's called like a blow-off valve, or a wastegate, which wastes your boost. It's an internal wastegate to the turbocharger housing, meaning it doesn't have it doesn't let it go out of the exhaust. It depletes the turbo pressure within the exhaust, so you don't get to hear that pew 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 noise. Anyway, I've checked out all of the actuators, the electronics. we've looked at the piping, we've looked at the charge air cooler, and nothing seems to have any leaks. Now, I drove this with the scan tool on it, and it was making about 3 pounds of boost. That's not gonna cut it. So that gave us our under boost condition. So now what I'm gonna do is we're gonna nose this thing back in, and I would like to actually physically check the actual valve seal inside of the turbo to see if the wastegate is making a seal where it's supposed to, because I believe that the turbo is trying to produce pressure, but it's all just dumping out through the wastegate and none of it is reaching the intake manifold. So what we're gonna do, since we're out here in this little parking lot here, we're gonna nose the car in. It's a cold start, it's not run in 2 days. We're gonna get it on the rack over there in the corner so I can get to some work here. Let's make this snappy because I do not want to be working on a hot turbo. Now, there's an S10 in front of me under the hood here, or above the hood. We'll do a video on that one too. It's an intermittent stalling while driving, and it's been all over town, people throwing parts at it and nobody can figure it out. I think I figured it out. I've used the scientifical method of diagnosis. Anyway, we're pretty close-ish on the lift here. Yeah, we can rack it up if we need to, which I probably will. Let's park this bad boy. Shut her down. Oh, by the way, this vehicle here has 69,037 miles on the odometer. So let's get started. We're gonna crawl out under the hood, start taking apart a turbo, and see if I cannot figure out exactly why this engine will not make any horsepowers. So stay tuned, because this is gonna be a very good video. This car is here for a P0299 turbocharger underboost. This is a 2020 Chevrolet Trax 1.4 liter. Now, I'm gonna tell you right now, we're not gonna get around to the fix on this one today because this thing's expensive. This little Econo box has suffered a major failure. It's got broken metal cracking components inside of it, and because of that, the system is not performing as designed. So stay tuned, this is gonna be a very good diagnostic video. Yes, this is a familiar sight. We have spent some time on these 1.4 and 1.5 Ecotechs. So, like I had mentioned earlier, we had checked for the check valve inside of that intake manifold, and it's covered in carbon, but I can see the end of the nipple sticking out right there at the 12 o'clock position. Super tough to see, but it's in there. I went in there with a camera too, so that nipple is there. I will be recommending the intake manifold replacement on this because the orifices on that nipple inside of that check valve are loaded up with buildup, and it is going to cause a failure, which will cause excessive turbine pressure to escape through here, and we'll end up with that doom loop of boost that we discussed in the last video. On one of these engines. Now, someone's been trying to remedy this underboost condition. They've installed a new ignition coil right here. If we have incomplete combustion, like misfires or a dead cylinder, then we don't have the driving forces to operate the turbine. So it stands to reason that people would have thought to go ahead and do the tune-up on this to see if we can't get some turbo pressure back. It also looks like they've replaced the PCV valve assembly system right here. This is a new hose. This little valve here, that's a purge solenoid. That solenoid is designed to purge fuel tank vapors from the gas tank, pull them up into the engine via engine vacuum, and reburn them through the combustion chamber. So someone's already replaced that, trying to fix this issue. Someone's replaced the coil, trying to fix this issue. So like I said, we're gonna have to diagnose this issue. Now, I wanna make sure that the turbine, that's already loose, that the turbo is actually turning, because we could end up with a situation here where the shaft has become broken. Come here. And if the shaft is broken, then we won't have any turbo wheel actuation, and then we have no boost. Now, the housing on this turbocharger, see it's got this big elbow thing right here. The turbine is located right inside here. There's our compressor side, and over here, that's our turbine side. So our exhaust gases will come out through the manifold. They go into the housing here. Those gases are gonna wrap around that housing, and in the middle of that housing, you're gonna have your blade for your turbine side. That's your drive blade. The gases are gonna rotate that blade, which will then rotate the shaft. The counter blade on the other side is located in this housing right here, And as that turbine compressor wheel turns, it's going to suction in air through here, pressurize it, and then send it out through this pipe down here, which will then plumb around and into the intake manifold and into the engine. Okay, so I will be inserting a little camera on a wobbly stick down here, and we're gonna drive that around the corner, take a look at the compressor wheel. There she is right there. Now Lauren has climbed into the cabin and she's gonna start the engine, and we're gonna see if this turbo wheel is gonna start spinning or not here. Let me get the right angle for our dangly bit. I can't see it. Oh, there it was. I lost it. I found it. There it is again. There's our turbo wheel. There she is. We were right up on it too. Let me pull this away just a wee bit. There it is. There's a lot of buildup on that wheel. See that? All that carbon nonsense? That's because this engine lives on junk oil. This is crappy oil. What's happening is that oil is going through that bypass valve, running down this tube, and it's exiting into the inlet housing for the turbo. See all that coking in there? And then that oil is embedding itself on the blades of this turbo. That's not a good look so far. Let's get this turned just right. All right, Laura, go ahead and start the engine, please. Just for a second. All right. Shut her down. Okay. So we know that turbine wheel is connected to its drive wheel. Turbine is connected to the compressor. So we know the turbo did not physically break inside. Sweetheart, I have no more need for you to start the car at this time.
Okay, can
Yes.
I come out?
Yes, ma'am, absolutely. Thank you, dear. Okay, so let's see if this thing is actually holding pressure after the turbine produces some boost pressure. So what we're going to do is take a look at our wastegate. This is our wastegate diaphragm right here. This is the linkage rod connection. This is the operation lever. There's a shaft right here that goes down into the turbo, and 90 degrees off that shaft there's a little flapper valve. That flapper valve is supposed to close and keep closed the bypass / blow off section of that housing. So what we're going to do here is pull this little clip off, and we're going to inspect the condition of the shaft that's already hot. That right there. We're going to inspect that shaft to see if that shaft is worn out. Because if the shaft is worn out, then we may not be making a good seal. And that would be bad. Okay.
I have the cart.
Open, close. Yeah, I see there's some play here. Okay. I would like to get an eyeball on that valve inside. So we can do that a couple of ways. We can lift the car up, take the catalytic converter off, remove a bunch of the exhaust, and then we can look up through the hole and kind of see. Or I'm going to try to cheat and do this the easiest way. Let's pull the O2 sensor out of it. We'll take our flexi camera, put it in the hole, and then try to fish our way up to take a look at that valve. Let's try that. So I need to get I think it's a 21 mil wrench. There's a 22. Perhaps it's 22. Let's put a wrench on that O2 sensor and see what happens here. 22 it is. That's awkward. Odd angles here. I wonder how I can do this. I need to put weight down on it. Oh no. I can't get any leverage. Let's put a pipe on. That open-ended wrench idea is not going to work because even if I put a pipe over it, it's laying like right here, and I won't be able to get a turn out of it. So we're going to switch out to the actual tool that is a O2 sensor socket, kind of like a line wrench. We're going to put that guy on there and then slip a ratchet onto it. I think it's kind of tight on the angles there, but that should work. Got a big O extended flex head ratchet. Let's see if I can't get this guy to get us to come off there. There we go. Oh goody. See, the right tool matters. There we go. Couple turns with the wrench. See, this is why we didn't get this thing super hot. Oh look, someone put a new fan in this once too. They've replaced everything except the turbo. Oh, come on out of there. I don't want to take the plug off. There. You gotta let the wire twist up too. Okay, set that thing aside. Now, let's go back in with the cam. Feed that guy through. In the hole we go. Alrighty, so that's our O2 sensor hole right in front of us right there. We're putting that cam in the hole. Right there, we're looking at our, let's turn this some. There is our turbine. There she is. Turbine's good, and then right next to it, right here, that should be our wastegate. That is our wastegate. Let me get this centered right. Okay, so what I'm gonna do, that's our actual valve. There's a hole right here behind it. The pressure is going to be relieved through that hole when this diaphragm pushes this lever out to actuate this rod right here. See that little rod? So I'm gonna run that rod. You see the wastegate opening up, right? See it? So that's our wastegate. So now it's in the open position. So we're closed and open, okay? So let's back the camera up so we can see around. There's our hole. Look at that. Look, 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 look. I see it. Oh, you see that right there? There's a big old crack. Let me get this set up. There it is. Look at that big crack right there. Now, those cracks are actually common in these, but that's a big crack. And another thing I see, do you see all the wear right here? Look down here. Excuse me. We have wear on the face right here, but no contact down here on the bottom side of that crack. That means this housing is warped some. Let me try to rotate. Get in a little closer on it. Yep, contact marks here, no contact here, and there's a second crack as well. Yep, two cracks. One at the bottom, right there, and then one right there at that 10 o'clock position. Let's go a little further if I can. I want to get real close up to that housing. I don't know if I can get in any deeper, like, oh yeah, we're turned all the way around now, look. We're backwards. There's the hole we just came into. Yep. Okay. I think I've seen enough. it appears that the turbo has failed. The housing is cracked, it is warped, and what we didn't discuss, because we didn't lose all of that boost volume through just one crack, but there's one other little problem here that's caused this thing to go under boost. Let me show you real quick. I know what it is. Bear with me, folks. I'm messing this all up. Okay, we need to go the other direction. No, turn. There's the cat converter. Converter looks good. We're going the wrong way. I need to go left towards Albuquerque. Okay, I've got us there again. There's one of our cracks, there's our other crack. Now what I'm gonna do, reach down here and I'm gonna close this valve. I'm gonna watch this valve come closed. All right, so the valve is closed. Let's back off just a wee bit. Don't fall, camera, don't fall. Let's pull it out a little bit. See that crack one more time? There's our shaft. Let me wiggle this shaft a little bit. See that? Right there, see that? All that motion? All that motion is me going up and down on this, but it's translating into this valve walking sideways, and it's not fully closing. Let's put that rod back on it. Let's see if we can't get around this valve to look and see if it's still open. There we go. Yeah, right here. That valve is open right there. Watch this. See if I just wiggle that. Our valve's opening. Yep, right there. And I didn't rotate it. I moved it. Up and down play. So the up and down play, this way and this way, is causing that thing to actually open because of the worn out bushing on the shaft right there. So we've got a turbo failure on two different failure modes. I'm going to recommend that this Chevrolet Trax needs a turbocharger. That's what we have to do. Replace turbocharger at what, 60 something thousand miles? Not great. Small engines doing twice the work with turbochargers. The candle always burns brighter when lit from both ends. Okay, so I realize you're a little probably dissatisfied because I'm all done with that one right now, but I'm not going to leave you hanging. We're actually going to fix something today. I've got a box of some parts over here. We also have next to me this this S10 pickup. This thing is it's kind of a diamond in the rough, man. These things are jewels. I love these old S10s. They were efficient, they were compact, they served their purpose, they were reliable, and they did what they were supposed to do, and they look pretty good too. I like these things. This one is equipped with the, I think 2.2 or 2.4 or 4-cylinder, and it is a manual. Definitely a rare gem, a manual 4-cylinder Econobox S10. How about that? And it's got the big bed. Let's go ahead and let this one down real quick like too. We're gonna diagnose and repair this one. I cheated. I've already kind of figured out what's wrong with this one. I used my brain to make the determination. This truck has been all over town trying to have this issue repaired. What this one is doing is intermittently the truck will just shut off and then it won't restart. Now they thought it was an ignition type of situation, you know, spark plugs or wires. They've gone through and done all the tune-up stuff on it, and every now and then it would still just shut off and then not restart for a little while. You'd have to let the thing cool off and then try again later, and then it would fire up. So let's get the scan tool out. I'm going to show you guys the codes that are in here, and then we're going to go through some common sense diagnostic thought process procedures to pinpoint exactly what's going on. This one's kind of a hypothesis as well. A hypothesis, that's an educated guess. That's when you don't have any concrete evidence, but all the evidence points towards this thing right here. So we're going to utilize that method to come up with the actual solution on this S10. Now, I realize that a lot of the people viewing this particular video are here because of the P0299 on the Chevrolet tracks. That's a super common code. It's also common, like I said, on the Malibus and the Equinoxes, anything that has that engine in it. Oh, there's my plug right there, hanging out with its bracket missing. And anyway, I realized that most folks are here for the Diag on that 299 because they Googled it and it populated a YouTube video, and you clicked on it, and then you scrolled through the video, and then you got to the turbo part, and then you figured out that, hey, I need to check the turbo in mine. But that does not mean you should not stay for the Diag on this one. Now, let's turn off those high beams. Yeah, they had the high beams on because there's one light bulb that is out. Anyway, let's turn those off. Let's shut those off so they don't drain my battery. It's not working. Anyway, we're gonna go in the scanner. We're gonna pull up the trouble code on this. Now, one thing to notice every time you get inside of your vehicle, this is especially applicable to people buying a used car. When you key this on and your Christmas tree lights up, you should see your check engine light illuminator illuminate somewhere, right? Now this one is not showing up. Let me key it on again. We do our self check and the light is out. Now, this being an older car, there was a light bulb in there that actually completed that circuit. The bulb may have been burnt out, or someone removed the cluster and removed the light bulb. That way you would not see that the light is on. Most people just put tape over it, but some will actually go through the effort, like the buy here, pay here lots. They will go through the effort and actually remove said light bulb. So anyway, we've got ourselves an 2003 and 03 S-Dime Chevrolet truck here. Let's go ahead and pull up auto ID, I guess. Let's pull up our code and I'll show you the code that we're getting. Now your Diag process, the direction you're gonna take is gonna start by prioritizing your codes menu, okay? So we're gonna pull up some DTCs here. We're only interested in powertrain. Transmission doesn't care, radio don't care, HVAC don't care. Lighting modules don't care because we're dealing with a running and stalling problem. We have to stay focused on the issue, okay? So what we have here, we've got 3 codes here. P0, let me move the cursor. P0336 CKP, that's crankshaft position sensor A. 18 by 24, that's our signal frequency. That is out of range. So this is saying that our crank position signal is out of range. So most of these engines, they're gonna have a sensor that tells the ECM where the crankshaft is at in relation to its top dead center position off of cylinder number 1. Top dead center is when the engine is ready to fire. That means we have fuel and air compressed in the piston, the valves are closed, spark plug's ready to go. It's as high up as the piston goes. That is top dead center, and it's always taken off of cylinder number 1. So in a 4-cylinder, that's the farthest forward one or the one closest to all the pulleys. So TDC on compression stroke number 1, what it's saying is that the sensor that monitors where that crankshaft is and how fast it is rotating is out of range. The ECU is seeing information from that circuit that it does not agree with. So it's got a range of numerical values that it would expect. There's a range here, or starting at 0 and ending at wherever. And what it's saying is the signal that it's receiving does not fit in this bracket. So it threw the code and said, hey, we're out of range, we have a problem here. Okay, so our next code, we have a P0420, catalyst efficiency low, bank 1. This code is simply saying that the ECM has recognized that the O2 sensor that is downstream of the catalytic converter is giving it information that allows it to calculate an inefficient converter. So the converter is not seeing the information it's supposed to out of the downstream O2 sensor. That code will not cause intermittently failing to start or have it stall, mostly, okay? Next code, P0452, evap pressure sensor signal low/short, okay? So the evaporative system, that's the system that will draw fuel vapors that accumulate in the fuel tank, not the liquid, but the gas. It'll draw those vapors out of the fuel tank, pump them into the engine, and then just burn them. That way we're not venting raw hydrocarbons into the atmosphere. So a failure with this system will not affect this engine stalling or running. So we have to focus all of our efforts on CKP sensor A, crankshaft position sensor. That's a very important sensor, because if the ECU does not know where the engine is at and what it's doing, how can it fuel? How does it know how to shift? How does it know how to change valve timing if it has valve timing? There's a lot of things. Everything needs to be based off of what that engine is physically and mechanically doing. And if the ECU doesn't know that, then it cannot do its job. So we're gonna focus on that P0336 crankshaft position sensor circuit performance fault code. So let's go ahead and shut that down. We gotta do the key, give the key the Chevy wiggle to make it come out. You Chevrolet guys know about that. Ford guys know too. Ooh, another thing, S10 people, we all know about that creaky door. Yeah, who knows about those creaky doors? Comment below which one of your cars creaks when you open the door. And how old is it? I'm curious as to how many of us live with the creaky door syndrome. Or even worse, how many folks have a creaky door and never realized it's not supposed to do that. All right, so we're gonna stroll on over here to the Alldatas, and we're going to pull up this Chevrolet S10. Like I said, before Thanksgiving, I was in here poking around diagging some stuff, so I sort of know what direction we're gonna go in. We're gonna go into P codes, because P is for powertrain. Let's see, P0, I went too far, 336, correct? 336 crankshaft position sensor circuit indicates the crank speed and position. We talked about that earlier. So we're gonna breeze past a little bit of this information here. This basically tells us what the circuit affected is doing. It's the ECM looking at the position and speed of the crankshaft. It gives us conditions for running the test for this trouble code, meaning basically it has qualifiers before the self-test can begin, which happens every key cycle because this is a primary sensor for fueling operation. The conditions for setting the DTC, this describes to us that the reset counter, the CKP resync counter increments more than 15 times within 4 minutes and 15 seconds. So we've got a crankshaft and a camshaft. Those two have to be in correlation with each other. And there is a counter system that monitors the correlation. So if it finds that the counting system between ticks on the crank and ticks on the cam do not match more than X amount of times within X amount of seconds, it will set the code. Those are conditions for setting the code. So it basically recognizes that the cam and the crank are not giving the same information to the ECU, and it says, hey, I don't like this, I'm setting my code, okay? So what the action is taken when the DT sets is the control module will turn on the malfunction indicator lamp. That's the MIL, that is our check engine light, on the second drive cycle that it fails. So if it fails while you're driving, it won't turn on the light. You turn the car off, then turn the car back on, bam, the light's on. That's why a lot of times when you guys get in your car, the light will be on, but it wasn't on 2 minutes ago when you shut it off last, okay? So it'll set the illuminator indicator light, that's our check engine light, and the control module will record all of the information that took place at the time of the failure. That's basically what we're saying here. Actions required for clearing the DTCs. The control module will turn off the indicator lamp after 3 ignition cycles where the test does not fail. This is why when the guy will let the car sit for a while and it cools off some, and he goes to start it again, it will just go ahead and work because the conditions are no longer present, meaning the ECU is recognizing the crankshaft's position through the sensor circuit. It did that 3 times so that then the computer can say, okay, we're good now, it's not broken anymore, I can turn my light off. The other way to turn the light off is to use the scan tool and manually clear the codes out, okay? Moving on, it gives us some symptoms here. You'll have a no start, a start and a stall, erratic performance, and it gives us a couple possibilities for what could be the cause. We're talking about crankshaft in play right here. That's the crankshaft's ability to kind of move forward and backwards in the block. Let's see if we can see one. You got a crankshaft down here. If this crank were to walk backwards into the block and forward, there was a bunch of play in there, like a thrust bearing is worn out, that would be considered in play. So if you have a crankshaft sensor sitting right here and this crank walks forward, you know, a 1/16 of an inch or something, it could disrupt the pickup field, the magnetic field between these little gear-like tick marks and the sensor located to count those as they rotate by. So if that crank moves forward, then it disrupts the pickup field of the sensor and could set the code. Now, I've already checked that with a pry bar off of the snout of the crank, and it does not have excessive in place, so we don't have internal engine failure causing this to occur. So we're going to move on. So we are basically looking here at the step-by-step flow chart to diagnose this issue. So every flow chart is going to start with a diagnostic system check, and that's basically your overall visual inspection. You know, the battery's connected, does the car work, does it turn on, does it do anything, do you have the criteria there to even test, is it not on fire, things of that nature. So usually we always skip past number one. Okay, so yes, everything checks out on the first inspection. Go to step 2. Does the engine start and run? Yes, go to step 3. Observe freeze frame records on the scan tool. Turn the engine off 30 seconds, start the engine, operate the engine while the condition is present. See, this is where flow charts get you. This is an intermittent issue. Now, I've never seen it happen. The thing starts and runs, and I drove it in and I drove it for a test drive and it was all hunky-dory. It seemed just fine. But the customer complains that it shuts off intermittently and randomly. Now, flow charts cannot account for intermittent problems. So we've got to go ahead and lie to this thing, right? So it's basically saying, you know, drive the vehicle, operate it in which the data told you the system failed, and it's asking us, did it fail this ignition? Well, I can go start that thing right now and it's going to work just fine. So the truth is no. So we have to lie in order to get the right information. So we're going to say yes, and we're going to go down to our next step, which is step 4 tells us, with the engine running, perform the wiggle electrical test on the connectors. What the wiggle test is, and I'm not going to do it while it's running because it's just going to get hot. The wiggle test would be, you start it and you run it, and let's say we have a manifold pressure sensor problem, okay? Well, the wiggle test is very simple. While it's working and running, you grab your wire and you start to wiggle things. You manipulate stuff, move it around, wiggle it, wiggle the harness, wiggle the ECM. Like for example, let's say I'm watching the scan tool and I'm looking for this map sensor to stop working. Let's just say that the wires for this map sensor go to this connector. And I come over here and I wiggle test this connector. And next thing I know, the pin moved a little bit and it broke connection. Well, now I've just located a intermittent loose connection to the sensor, causing a circuit code because the wiggle test found a bad connection. So that's why we always start with a wiggle test of the affected situation or a system or symptoms system. You wiggle it, trying to excite that intermittent condition, because there's a difference between a car sitting in a stall and we're trying to diagnose it, and there's a car going over railroad tracks, bumping and jostling around, and that's when the condition shows up. So we're trying to recreate road conditions here in a laboratory environment. Along with your wiggle test, you can also conduct a visual inspection on your harnesses. So you want to make sure that your harness isn't changing directions and rubbing through onto an AC line or a frame rail or things of that nature. You want to visually inspect, and you're looking for open circuits. So according to the pinpoint test on this flow chart, we're going to do the wiggle test on the harness at the PCM, at the ICM, and at the crankshaft position sensor. And it asked us, does the engine stumble? Now, I've already conducted said wiggle test, and the answer was no, step 7, indicating that my wiggle test and my visual inspection of the harness did not yield a short to ground or cut wires or rub through wire, so we can go ahead and move on in the chart. So we're going to scroll on down to step 7. It asked, did the illuminator illuminate in step 3? Well, that's pretty stupid, because we're on step 4. It tells us go to 7. Step 7 asked, did the check engine light come on in step 3? So let's go back to step 3 and see what this thing was talking about. Step 3, observe freeze frame data, turn the engine off, start it. Did it fail? See, this is why I hate flowcharts sometimes, because now we're going circular, because now it just sends us back over here to step 5. Okay. Step 5 is asking us to operate any non-related electronic components on the vehicle. Do you have a CV radio? You got an amplifier for your audio system? You have some floodlights, a winch? It wants you to operate any of those things and then determine if the operation of aftermarket components is affecting the OEM system. And the answer, of course, is no, which takes us back over here to step 4. See how the circular logic of a flowchart can be kind of stupid a little bit? It can be helpful if you know how to wade through the circular reasoning here, but it's frustrating. Very frustrating. So going through the circular logic, that lands us back on step 7 again, and it's asking us if the illuminator illuminated back on step 3. Let's just entertain both options. So we'll figure out where we're going to lie to it. So next, go to step 8 is a yes. So if the light comes on, which it is on, so I think we can go to 8. We'll go to step 8 next. If we have to, we'll backtrack and go to step 15. All right, so let's back out of here. Next page, going to step 8, the Ocho. Step 8 says turn the engine and the ignition off, inspect the circuits for rub-through wire insulation and being pinched at the PCM, the ICM, or the sensor. Now, we've already done that for our wiggle test, because if we're in there touching these wires, why are we not inspecting them? So we could have combined this test with a whole another test, and that would have been fine. But it's asking us, it says refer to diagnostic aids and wiring repair procedures. Did you find and correct the condition? No, we did not find it. No. So now we're going down to 10. It says remove the crankshaft position sensor from the side of the engine block. Visually inspect the sensor for the following conditions: physical damage, loose or improperly routed wire, loose or improper installation, excuse me. So is the sensor shoved in sideways? Did they not put the bolt in? Did they break the bolt off and just glue the sensor in? Things of that nature. No, I don't think we have that issue, but we're gonna check it. And it's looking for, again, a wiring issue. Did we find and correct the condition? Well, we're gonna assume that the sensor's fine, so the answer is no. It's putting us back at step 15 again. Going down to 15. Clear the DTCs with the scan tool, turn the engine off, start the engine. Now these have been cleared because people have already tried to fix this. So this has already happened once before. Operate the vehicle. Did it fail this? See, did it fail this ignition, right? We know it's intermittent, we know it's going to fail. But if it didn't fail this ignition, then everything's fine. System okay. Step 16, system will ultimately be okay. And if it did fail this ignition, our circular reasoning sends us right back to step 2 where we started from. Attempt the start the engine. So basically we're just gonna sit here and turn it off and turn it on, turn it off and turn it on, turn it off, turn it on until it finally stops working, and then we can do whatever part it tells us to work on. So let's back up the 30,000 foot view here and get away from this circular reasoning flowchart. It can be useful, but it's not the procedure. The procedure comes from your head. So what we're going to do now, we're going to go to diagrams. We're going to go to electrical diagrams. Go right there. And we're going to go down to powertrain management, because these sensors manage our powertrain. And we're going to go ahead and we're going to look for the crankshaft position sensor. That's the affected sensor. So let's find it on our graph, and then we'll see what wires are. No, where'd you go? I did too much zoom. Bear with me, folks. Touch screen. It's dirty too. Okay, so here is the representation of our crankshaft position sensor. It's below the ignition coil on the right hand side of the engine. That's passenger side of the vehicle. Okay, so let's see what this thing is doing. There's our sensing element located inside right here. Got a yellow wire and a purple wire. Now, according to our description, this device is supposed to talk to our engine control module. Where's that at? ECM, that's over here, right? So we've got a component under the hood talking to a component bolted to the engine. So how do we communicate? We do that with electrons and with wires, okay? So what is this? This thing is not wired to the ECM over there. It's wired over here to the ignition module. That's our ICM. We heard us talking about that in the flowchart, right? ICM, which is what controls our spark plugs through our ignition coils, commanded by our ECM. The ECM is wired to the ICM. The crank position is wired to the ICM, and then the ICM tells the ECM what the crankshaft is doing. So you got two wires going into ignition control, purple one and the yellow one, and then we should have two more talking back to our engine control module. There's a pink one. Nope, that's not it. So it's not the pink one. And it's maybe the orange one. Let's check the orange one. Orange one goes, oh, we got a winner. Orange one goes right here. Ignition control 2 and 3. That means ignition control 1 through 4. This is the ECM's communication wires telling the ICM which coils to fire. So that would mean the purple and this red might be our winners for crank signal. No, that one goes, oh, yep, here it is. We have another. Both of these are ECM on this graph. ECM is over here represented, and it's also represented over here. Same component, but the graph has to split it. So I found the wire. We got a red and black going to our ECM, and we seem to also have, it's not the gray, might be the gray. Bear with me, I'm trying to figure out which wire it is. This one, this pink wire, purple, I'm sorry, purple wire. CKP reference, this guy. Following, highlighting, I got my wires crissy-crossed between pink and purple, but we follow that right down, reference signal right straight to the ECM. So what we've got going on here is crankshaft position is talking to ignition control through those two circuits on this graph. Ignition control then is communicating with the ECM. I believe that this right here, ignition control module, is the problem. And I'm going to show you why when we go take a look at where the sensors and the modules are located. Smash the subscribe button. Moving on. We're going to go in through the wheel well. We need to get access to the side of the engine block, which is where the ignition control circuitry is located. I think right about, that's good. Okay, coming in with some light on the subject here. So, here's what we're looking at. We've got our blue oil filter reference. Right here, that's our engine oil pressure sender. That is our camshaft position sensor. Now, what do we notice about that cam sensor? It's shiny and gray and new, right? Now, just below that, down to the left, we've got a crank position sensor. What do we notice? Shiny and gray and new, okay? Now, the ignition control module, that is located behind these two coils right here. Got a coil for 2 cylinders and another coil for another 2 cylinders. That's where our fire comes from for our spark plugs. The ICM is sandwiched between that plate and these coils because it has to connect to those coils to tell the coils when to fire and when to trip their magnetic field, okay? So I think that the issue is when that module right there heat soaks, we're going open circuit or getting a resistance issue for the circuit relay activity regarding this crankshaft position sensor. So we know it's not the sensor. I know it's not the actual crankshaft in play because I've checked all that. What we don't know and what we can't test, because the flow chart is stupid, we can't test what that module is doing when it gets vibrated under certain heat conditions. Yes, I could invent a laboratory that heats the thing up, that we connect it to meters and then heat it and then vibrate it and then stare at it and wait for it to go open circuit or wait for resistance to change. We're not going to do all that. That's asinine. I'm just not going to happen. It's not reality. We can't test that. So we have to hypothesize in this situation. We've got to take our best guess, and we have to look at this holistically from a 30,000 foot view and utilize processes of elimination. What is it not? And based on what it's not, that can help determine what it is. So based on that determination, I've ordered an ignition control module. So we're gonna pluck that thing out and swap it out, plug the new one in, and then we're gonna start this thing up. We're gonna drive it, we're gonna see how it runs, we're gonna get it warm, and see if we fixed it. The problem is, because it's an intermittent, we don't know if we fixed it or not. It'll have to go out into the wild, in the real world, back to the hands of the fellow that owns it and drives it and loves this thing. And he's got to take the risk to go out and drive it, and hopefully, probably, and maybe, it will not foobar for him, and we won't have an issue. So, what I need to do, I'm going to pull the spark plug wires off of this first. I should label them, but I'm not going to. I'm hoping that I can just figure out where they go. You guys won't forget, will you? We're just going from the top down, right? There's one. Put that up there. I can't get it over the thing. Get up there, you. There we go. Yeah, I should label these, but there's only 4 of them. That means there's only 16 different possible combinations for me to get that wrong. So based on all those combinations, I can right my wrong using process of elimination. So these are our control wires from our ECM to tell the ICM what to do and to relay information. I'm reaching around behind this and plucking these guys out. You gotta pull the tab and just sort of tug and it'll come out. So we'll stick those off to the side. I'm gonna disconnect the NOx sensor if I can, just to get that out of the way. So now we're left with 3 13mm fasteners. One there, and one down there in the corner. Hence the extension and the swivel. So bear with me on the hard to see mechanicals here. Just trying to get through this. Unclicks. There is also no easier access from the bottom to do this. Through the wheel well is going to be the most pain-free method here. The second one, staring at us in the face, right there, nice and easy like. Unclick. Yeah, it's a slow paced day around here. You know, bear with me on this one. That should be the last of the bolts. Now, up here there's a purge valve. We just talked about those on that other Chevy. That purge valve shares this bracket. Oh, there's another bolt. There's a nut on that one. Okay, so there's actually 4 fasteners that I have to remove to get this ICM out. And GM called for 0.8 hours on this thing. That's not fair. This is way harder than 0.8. Especially since these bolts don't want to come out. Power tools. Now we can take this assembly and squeeze this out through this hole that doesn't fit through. There we go. Okay, so we've got a coil pack, 2 coil packs. Got a bracket, and then sandwiched in between there is our electronic control module. Okay, so we must remove these ignition coils. This will require the infamous 5.5 millimeter socket. We unbolt the coils from the module. One and two circuits, these were represented on our graph. So through those two pins is how this module tells these coils when to fire. And pull those guys off. And this is our control module. That's what was in the AC Delco box over there when we got started. That's our ignition control module. Inside of here is where I suspect the fault to be, disrupting our communication between that sensor and the ECM. So we're going to install a new one. This guy up right here. Oh, I dropped some goodies. Those are our weather seals for the pins. They came bent. Very good. Anything else in there? Thermal paste? Nope, none of that. So looks like all we've got to do is make sure this matches up. Connector to connector. Looks good. Dimensions are good. This is our guy. So let's plug these guys over the pins and then reverse procedure. You know, I guess the only thing to do when the parts cannon has been fired is fire a second volley, isn't it? Because this truck has already been parts cannoned. They even put a crank position, or I'm sorry, cam position sensor in it. I don't know why you change a cam sensor for a crank code, but hey. While we're in there, right? Get rid of that dirt. That goes right like so. You know what? I mentioned thermal paste. I don't have any thermal paste, but I do have some dielectric. We'll use that. This actually may be a little bit overkill. On the Ford ICMs, they have you install a thermal paste because there's a heat sink on the back of the module. Now, I believe the engineers have determined that there's enough aluminum right here to serve as a heat sink, but it wouldn't hurt to allow some kind of contact between that heat sink and this guy right here just to help it out some. So I don't see a real problem with installing any dielectric in here. We'll put some on the pins too just to keep moisture out, because why not? We do not need it for the coils. Go. We didn't really need it for the module either, but the Fords use it, so if it's good enough for a Ford, it's good enough for this. Clicks. Little clicks. Excellent. So, I'm going to take this guy, go put it back where it goes. I'm going to start it, run it, and drive it. Alright, we return back to our dingy low light condition wheel well. Let's go ahead and sneak this thing back in where it belongs. Right there. Bolt. Okay. Long range bolt starting tool. That's my socket on my swivel on my extension. Because it's far away. There we go. That's awesomeness. Okay, next fastener way down in that corner. Can't even see it. Yeah, I believe this one is starting. Feels like it. Sort of started. I can't get the necessary twist on it due to my flat flanges. We'll use the extension and do the same method. Okay, good. Okay, third bolt, bottom left-hand corner. That one's a tough one. The wires are, yeah, I can't reach it. And I dropped it, gravitas. Here, let's give it the backwards other arm, flip it around treatment here. It's in there too. Nice and deep like. But I can feel it. Almost. More almost. Almost more than that. And I'm failing. I can't, ow, nope, stuck. Ah, stuck. I failed, I couldn't get it. I'm gonna have to try to reach up from way down here at the bottom. It's gross down here, there's a bunch of oil. Problem is I'm the problem. Yay! I got it, folks. The problem there is the weight of that assembly was pushing down and it was blocking the threads, so I had to push up on it at the same time. Right, I'm gonna go ahead and tighten that down. You got to spend enough time in this wheel well. Let's get you out of there. Let me tighten that down and plug it in, and we're gonna let this down and fire it up. Do this quickly, like, let us exponentially complete this process, or we'll speed it up exponentially. Yeah, you know what I meant. Click. Huh? PCV, put that thing back. Then there's the one nut to hold the PCV bracket in position. No nut. Forgot where all those spark plug wires go. I totally forgot. The last nut's not threaded because it's far away. There it is, got it. Okay. 2 connectors, 4 wires. Okay, I believe that's how we found it. So let's back her out, let it down, fire it up, warm it up, drive it around, see what happens. Coming down. Like, subscribe button. All the way down. Beginning anticlimactic engine stalking sequence. Now. Okay, well, so far so good. Purring like a kitten at 160,708 miles on the odometer. And there's the 2 for 1 today. So we're gonna go drive this. What I want to do, we're gonna clear all these codes out. Now the light's gonna turn off, the one that's not there, and it's gonna clear out all these codes, primarily the 336. Okay, the CKP sensor A. We've already lost got rid of the fuel tank code. That one went away. But I'm gonna go ahead and clear these out before we go drive it. That way, if we do have a signal problem on our crankshaft circuit, it will recode and then give me some data again. So let's go back into codes, just check it, because I did do it with engine running. Our 452 code just came back, even though we just saw it leave. That's fine. Shut it down. Restart. Clutch. Do the neutral wiggle. Let's get my connector disconnected. We don't need this guy anymore. Pull that guy out. And I need to hop out and get this thing off the rack because it's still elevated and levitated. Okay, we're off the rack. Da da da. Uh-oh. There. Still purring like a kitten. 2.2, not 2.4. I said 2.4 possibly earlier because I forgot. All right. That one and last one. Swing it out wide. Okay, back in. Let's see if I remember how to drive a manual. Put it in reverse. Look at that. Clutch feels a little short. Maybe it's got some wear. Honks for safety. It's not working. Beep. I'll just rev it up. The cat converter rattle. That'll let everyone know I'm coming out. Yeah, that P0420, we didn't talk about it, but you hear that rattle noise? That rattle noise is the honeycomb structure inside of the converter rattling around inside of the housing. The converter itself is falling apart, and the catalyst bed is no longer providing a catalyst effect on the exhaust. Therefore, the O2 sensor is reading that, which is what's there in the code. So that P420 code will guaranteed come back. That's actually one of the few trouble codes that equates, what are they doing? That equates to a part number. P420 usually means replace cat converter. P430 usually means replace the other cat converter. All right, the heavy traffic has broken. We're ready to ride. Drives like an S10. Feels like an S10. I like it. Yeah, I don't expect us to suffer the problem here. This is an intermittent. I don't think it's gonna do it for us, but what I'm gonna do is drive it down the road about halfway to Sarasota. We'll drive it back. All right, y'all, we're riding along. I'm gonna drive this about halfway down to Sarasota, and well, 4 or 5 miles. We're gonna bring it back, make sure this thing gets nice and warm and heat soaked. I'll get back to the shop and we'll do a couple key restarts. And then we'll see if it stalls. I don't think it's going to. I don't want to drive it too far though, because I'm gonna tell you what, the steering on this feels kind of scary. It doesn't feel that great. Hi. Hello. Oh, you got nothing to say now. Hey there, yo. Yo. Anyway, I'm headed back down. We're gonna go back to the shop, do a couple more restarts, but I'm supremely confident this thing is good. However, this right here, this was scary. One thing I also noticed while driving is that when you brake, this thing wants to kind of pull off to one side and the steering wheel likes to turn. I also noticed during a sharp turn, I heard some popping, banging noises coming from the left front area. I think it has either a bad bushing or the shims have fallen out of the upper control arms and the control arm is moving around, and or it has a brake biasing problem due to sticking calipers. So I don't know which one it is, but now that it's running and driving, and I think reliably, we're gonna go ahead and do an inspection on it, and I'll let the owner of this thing know that there's some other stuff that it needs in order for it to be considered a safe vehicle to operate on public motorways. So anyway, guys, I think we have a win on this one. Appreciate you guys watching. I'm gonna go ahead and close this now. Let me know what you think about the contents of this video in the comment section down below. Do not forget to engage that like and subscribe buttons while you're down there. That kind of stuff helps out the YouTube channel immensely. And most importantly, have yourselves a fantastic day. I'll see you guys later. Thanks for watching. Thanks for tuning in. Thanks for staying to the end, and thank you for your comments, your like buttons, and your subscriptions to the channel. See you on the next one, Into Transmission.